So for problem 8.3.2, it wants to know how many milliliters of water at 23 degrees Celsius with a density of 1 gram per milliliter must be mixed with 180 milliliters of coffee at 95 degrees Celsius so that the resulting combination has a temperature of 60 degrees Celsius. And we can assume that coffee and water have the same density and the same specific heat. So essentially, we can say that the Q of the water is equal to the opposite of the Q of the coffee. So mc delta T for the water is going to be equal to the negative mc delta T for the coffee. We don't know the mass of the water, that's what we're trying to solve for. We know the specific heat of water, 4.184 joules per gram degree Celsius. And we know that the change in temperature of the water that we desire is that it ends at 60 and starts at 23. And that has to be equal to the negative of 180 grams of coffee, because if I have 180 milliliters and I assume the density is 1, I also have 180 grams, times the specific heat of water, which they said was the same as the specific heat for the coffee, times the change in temperature here. It wants to end at 60, but it's going to start at 95, so my delta T is going to be negative in this case. So here, I'm going to wind up with 154.808 times the mass of water, which is what I'm trying to solve for, is equal to the negative of negative 26,359.2. And my units that I'm going to be left with are joules, because degrees Celsius will have canceled out and grams will have canceled out. Here, I'm still going to have joules per gram. So I'm going to divide both sides by 154.808. My units that I'll be left with will be grams, and the overall mass of water that I need to add is 170 grams of water, or 170 milliliters.